awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Assalamualaikum and hi everyone. So welcome back. Jadi dalam video kali ini kita akan discuss soalan. Ada 2 set soalan untuk awak bersedia bagi menjawab soalan UPS 2 yang merangkumi chapter 4, 5 dan 6. Alright, so for your information, UPS 2, okay, so you will answer 13 questions. So make sure you can answer all the questions and make sure you can score your marks and then try your best. Alright, so jom kita discuss soalan exercise UPS 2. Okay, kita mulakan dulu dengan soalan yang pertama. Alright, so now let's read the question first. Which of the following statements incorrectly define work done by constant force? Alright, incorrectly define work done by the constant force. Okay, basically this is about definition or concept of work. Okay, so let's read the first answer. So here, the scalar product between force and displacement of a body. Yes, work is the scalar product. So number 1 is correct. And the product of magnitude of force and component of displacement. So remember that the unit of work, so it is the scalar product F dot S and F as cos theta. Okay, so the force and the displacement should be parallel. Sama ada dia parallel in the same direction or parallel in the opposite direction. So kat sini kita akan dapat work sama ada positive or negative. So if positive, okay, remember, if positive means that work done, okay, on the system. But if your answer W is negative, means that work done by the system. Okay, so second, so this is the correct one. Okay, and then the dot product between force and displacement. Yes, W equal to F dot S. And the last one, the vector product. Okay, baca saja vector product, kita nampak salah lah. Dia bukan vector product, tetapi scalar product. Alright, so the answer is D. Okay, so question number 2. Okay, when a roller coaster cart falls towards the ground, what happens to its potential energy? So remember, when the object is at highest position, alright, let's say at this position. Okay, so when H is maximum, means that the gravitational potential energy should be maximum. Kalau semakin tinggi, semakin besar H, UG dia akan maksimum lah, since UG is directly proportional with the height. Okay, so what happen when the cart falls towards the ground? Okay, so kalau dia towards to the ground, means that height dia akan berkurang. Height dia semakin berkurang, so the potential energy also decreasing. Okay, so very easy, so the answer is B. Number 3, alright, so ini question yang ramai pelajar salah. Okay, so jom kita baca dulu. Which point along the roller coaster has the greatest velocity? Mana yang velocity dia paling besar? A, B, C, D. Okay, so first of all, make sure you tengok pada height. Okay, height of the position. Let's say here we have HA. And then here we have HB. Okay, and here HC. And here is HD. Okay, so look at HA. So if the object is moving from here, okay, look at here. So dia bergerak daripada sini. So means that dia akan ada velocity dia lah dekat point A, VA. Dekat VB pun akan ada. Sama juga dekat VC and also VD. Okay. So dekat mana dia punya velocity dia paling besar? Okay, now at point A, as we know at point A here, okay, the object has 2 types of energy, which are gravitational potential energy at point A and also kinetic energy at point A. Okay, remember, let's say at point A, alright, let's say the gravitational potential energy is 1000. Okay, saya main letak je dulu 1000 joule. Alright, and then at that point, the kinetic energy is 500 joule. So the total kinetic energy at point A should be equal to 1500 joule. Okay. And then the roller coaster will move to point B, right? Okay. At point B, what is the total energy at point B? So remember the conservation of energy, that total energy at point A is equal to total energy at point B. Jadi kalau dekat point A 1500 joule, means that at point B pun akan sama lah 1500 joule. Okay, cuma bezanya dekat sini, tengok kat sini, the height at point B, okay, height dia lebih tinggi, right? HB should be bigger than HA. Height at B bigger than height at A. Therefore, the gravitational potential energy at point B lagi besar daripada gravitational potential energy at point A. Okay, so kalau kita tengok dari segi nilai dia, that's mean UGB mesti lagi besar daripada 1000. Okay, so dia pun akan ada kinetic energy juga. So, if the gravitational potential energy is bigger, let's say at point B is 1200 joule, therefore the kinetic energy at point B, berapa lagi kita nak tambah nak cukupkan 1500? So, kinetic energy at point B akan jadi kecil. Okay, which is 300 joule. Compare kan? Okay, kinetic energy at point A is 500, but at point B is 300. Okay, and then at point C, you can see here that the height of point C from the ground, height dia adalah paling rendah. Okay, dia lah yang paling rendah sekali. Kat situ. Tak lurus. And the height is here. Lebih kurang lah So, if height at point C is smaller than HB, smaller than HA, therefore the gravitational potential energy at point C mestilah yang paling kecil. So kalau kita tambah dengan kinetic energy at point C, let's say at point C dia mesti kurang daripada 1200 dan dia akan kurang lagi daripada 1000 joule. Okay, so kita letaklah kat sini berapa? Let's say lah 800 joule plus. So 800 joule plus kinetic energy must be 700 joule, barulah jumlah dia akan dapat total energy at point C samalah 1500 joule. Okay, so tengok kat sini, besar tak kinetic energy at point C? Ya, besar. Jadi kita nampak dekat sini, bila point C dia yang paling kecil, yang paling rendah, dia punya kinetic energy dia akan paling tinggi. Okay, so the answer is C. Okay, finish question number 3. Alright, question number 4. So let's read the question. Work energy theorem is the work done by the net force on a body equals to the. So this is definition of work energy theorem. Remember that work energy theorem is equal to the change of the kinetic energy of a body. Okay, so the answer is C. Very easy. Same goes to number 8. This is the definition of power, right? So the rate of doing work. Perkataan rate ni maksudnya kena bahagi dengan time lah. Work. The rate of doing work, W over T, and this is equation of power. So the answer is B. Very easy. Question number 6. Okay. Which of the following is false about uniform circular motion? Okay. So remember uniform circular motion. Alright. So let's say here we have a circle. Okay. And then if we have object here. Okay, so let's say here we have V, so the direction of the speed. So let's say here we have the velocity, okay, and the magnitude is equal to 10 meter per second. But the direction at point A here is upward. But when the object reach point B, you can see here, okay, the magnitude of the velocity is constant, okay, but the direction is to the left. Remember that the direction of the velocity must be tangential to the circle. Okay? Tapi kalau kita cerita pasal centripetal acceleration pun sama juga. Okay? Direction dia always to the center. Kalau macam dekat point D, dia punya centripetal acceleration dia ke atas. Dekat point A, dia akan jadi ke kiri. Dekat point B, dia akan jadi ke bawah. At point C, dia akan jadi ke kanan. Okay? So, mana satu yang salah? Centripetal acceleration, whose direction is always points towards to the center of the circular path. So, betul. The motion of circular path at constant speed. Betul, the speed is constant. Speed tu kita tengok pada magnitude of V. V dia sama kan? 10, tidak berubah. The motion of a circular path at constant velocity. So, salah. Kalau constant velocity, maknanya magnitude dia kena sama. Kalau 10 tadi, 10 je lah. Magnitude dia mesti 10 meter per second. Betul. But, direction dia mesti sama juga. Adakah direction of V dia sama? Tidak. Okay, at point A upward, B ke kiri, C downward, D ke kanan. So, yang last kali salah lah. The time taken to complete one circular motion is period. Betul lah. Okay, so yang salah adalah C. Okay, so question B. Alright. Sorry, question 7. Okay, the figure below shows a top view of a ball on the end of the string. Okay. Traveling counterclockwise in a circular path, the speed of the ball is constant if the string should break at the instant shown here. So this is the position of the ball. Okay, the path that the ball would follow is okay. So jadi kalau dia kata kalau putus tali tu dia akan terbabas ke mana? Dia akan bergerak ke mana? Mesti dia akan follow direction of V that is tangential to the circle. So the answer is B. Number 2 lah. Okay. Contoh kalau kita ada soalan juga. Soalan kereta kan. Kalau kereta. Contohlah kat corner sini kan. Dia pusing. Sama juga kalau terlebih speed. Kan terlajak. Terbabas keluar. Okay. Dia akan bergerak ke depan. Kalau kat sini. Dia akan tangential V lah. Dia tak akan tiba-tiba bergerak ke kiri kan. Ni. Dia akan terus ke depan macam tu. Okay. So the answer is 2. Alright, question number 8. Which of the following will increase the magnitude of centripetal acceleration in a uniform circular motion? Okay, so to increase the centripetal acceleration, we know that AC equal to V squared over R. Okay, so if you want to increase the centripetal acceleration, we should decrease R and increase V. Okay, so increase the radius? No, we should decrease the radius, right? Increase the mass? No. Okay, tak ada kaitan. Ini untuk mass ni kalau ditanya centripetal force, yes. You can relate the centripetal force with the mass, which is FC equal to MAC, right? So if you increase the mass, okay, probably you increase the centripetal force. Increasing the speed, yes. So here you can see, if V is increasing, what happened to AC? AC pun akan increase lah, directly proportional. So the answer for number 8 is C. Alright, question number 9. The easiest way to open a heavy door is by applying the force at the edge of the door far from the hinges. Why? Kenapa? You ada pintu. Ni pintu. Okay, sorry. Okay, so this is the hinge of the door. So this is the door. So we found that it is easiest way to open a heavy door if we put a force at this point. Okay? Ataupun saya ada color biru kat sini. Jauh sikit lah. Okay. Antara color biru dengan color merah. Okay, kita akan rasa, nak buka pintu dekat color merah ni lagi mudah. Kenapa? Okay, look at the distance. Okay, look at the distance of a point from the blue point from the hinge. We put as RA. But the red color here, okay, you can see here. So the distance of the red point, okay, you can see here, is far away from the hinges. Okay, means that if we relate R with the equation of torque, kita tahu torque adalah tendency of an object to rotate. Jadi kalau lagi besar nilai torque ni, sebenarnya kita akan rasa lebih mudah lah untuk buka pintu itu. Ataupun lebih mudah untuk objek itu rotate. Okay, so RF sin 90 degree. So in this case 90 degree lah. Okay, contoh daripada sini from the pivot point. Okay, kita ada RB. Okay, So kita tolak ke dalam ataupun kita tolak keluar, we put a force, right? Must be 90 degree so that your torque would be maximum. So here you can see that R is directly proportional. If R is bigger, increasing, means that torque also increasing. Okay? So kenapa? Okay, dia tanya why. Okay, force is the same direction with the perpendicular distance. No. Okay, kenapa nak same direction pula? Okay, torque apply on the hinges is 0. Betul. Tapi kita bukan cerita pasal torque yang apply on the hinges. Okay, torque is directly proportional to the perpendicular distance. Alright. Okay, so this is the perpendicular distance. Kenapa dipanggil perpendicular distance? Because the distance is perpendicular to the force exerted. Okay, so the answer is C. Yang D itu memang salah lah. Boleh Okay, question number 10. The angle through which a point, line or body is rotated in a specific direction, okay, and around a specific axis of rotation, let's say. Okay, so let's say lah daripada point sini, dia rotate from point A to point B. Okay, so ada angle. Okay, so kita panggil dia sebagai angular displacement. Okay, so the answer is B. Next, a construction worker is worried about applying too much torque to a bolt using his wrench. What could he do to reduce his torque on the bolt? So he want to reduce, right? Reduce his torque. Okay, so increase the length of the wrench, reduce the length of the wrench, increase the force on wrench, reduce. Okay, so kalau you increase the force, okay, here, if you increase the force, automatically torque is equal to RF, right? Okay, so torque should be increased lah. Okay, so means that R ini, bila kita nak reduce, R ini kita kena reduce. Okay, so means that the length, reduce the length of the wrench kat situ. Boleh reduce the friction between. Okay, tak boleh lah reduce the friction, kita tak boleh nak reduce, so we reduce the length. Okay, contoh inilah dia punya bolt tu. Ni dia punya spanner tadi. Okay, kalau asalnya dia macam ni, besar kan. So the distance, let's say we put a force here, so the distance besar lah, RA. Okay, but if he use shorter length of the wrench, okay, so in this case, okay, sorry for the bad drawing. Okay, we should use the shorter one. Okay, so let's say we put a force in this direction, at this point, so we are going to have RB. Okay, so when R is decreasing, the torque also decreasing. Okay, so the answer is B. Next, question 12. A woman sits on a spinning stool with her arms folded. When she extends her arms, which of the following occurs? Okay, so dekat sini you kena tahulah conservation of angular momentum, where momentum initial is equal to total momentum final. So equation momentum, that's mean the inertia, the moment of inertia initial. So means that the moment of inertia initial times the omega naught angular velocity, initial angular velocity, and this is the final moment of inertia times the omega final. Jadi kita nampak kat sini lah, omega tu, angular velocity tu, kalau dia besar maknanya objek itu rotate lebih laju. Jadi let's say this is the axis of rotation. Okay, so let's say we have the woman here. Okay, sit on the spinning tools. Okay, so what happened when she folded her arms? Okay, so kalau contohnya tadi, kalau contohnya tangan dia depakan tangan dia, kan, buka tangan dia macam. So kita boleh nampak dekat sini. Okay, the mass of her hands. So we can see here that the mass of her hands, okay, is located far away from the axis of rotation. Okay, RA. Contohnya. So jadi untuk woman, kan kita kira dia sebagai particle lah. So the moment of inertia for particle, formula dia apa? mr². Therefore, okay, when r is increasing, okay, r dia besar, the moment inertia dia akan besar lah. Okay, jadi bila moment of inertia dia besar, sebenarnya objek itu akan rotate lebih perlahan. Okay, omega dia akan kecil lah. Okay, contohlah, saya selalu suka letak nombor. Contoh masa dia depakan tangan dia tadi, the moment of inertia is 5. Besar kan moment of inertia dia. And then the angular velocity, let's say the angular velocity is 2 radian per second. So 5 times 2 is equal to 10. Okay, now what happened? Okay, what happened? Okay, when she tried to folded her arms. Okay, macam ni lah, pendek sikit. Okay, dia maknanya dia rapatkan tangan dia ke dada. So what happened? Obviously, the distance r here should be smaller, right? So when r is decreasing, the moment of inertia final akan decrease. Kalau tadi the moment of inertia dia, you tengok dekat sini 5. Okay, jadi ini 10 kan? 5 darab 2, 10. Jadi total angular momentum final pun mesti 10 nilai dia. Jadi untuk bagi you nampak, so I final, since she folded her arms, so means that the radius is decreasing, so the moment of inertia should be decreasing. So kalau tadi 5, sekarang saya nak letak 2. Okay, and then what happened to the final angular velocity? 2 darab berapa? 10 nak sama kan nilai dia. So 2 darab 5. So bila saya tak nombor, student nampak. So what happened to the final angular velocity? 5. Kalau initial tadi 2, sekarang jadi 5. Because the moment of inertia is decreasing. Alright? So, let's look at the answer. Okay? She decreased her moment of inertia, betul. Thus, increasing her angular speed. Okay? Dia minta mana kan? Dia kata when she extend kan? Okay? Maknanya, mula-mulanya dia folded. Okay? Tapi bila dia extend, apa yang berlaku? So, yang ni salah lah. Okay, sepatutnya bila dia extend ataupun dia expand dia punya tangan tu, dia buka, depakan tangan, the moment of inertia should be increasing. Okay, she increased her moment of inertia, okay, thus decreasing her angular speed. Betul, so the answer is C. Okay, maknanya moment of inertia is increasing. Okay, the moment of inertia is increasing and the angular speed is decreasing. Okay, maknanya kalau dia depakan tangan, kalau dia rapatkan tangan dia dekat axis of rotation, dia akan pusing dengan laju. Tapi bila dia depakan tangan dia, dia akan pusing dengan lagi perlahan. Alright, question number 13. Which of the following is not a factor that influences the moment of inertia of a rigid body which is rotating? Okay, so remember the moment of inertia depends on the shape, right? So ini betul lah. Kita ada disc, hollow sphere, kan? Kita ada sphere, kita ada cylinder ataupun rod. Okay, and then kalau particle, dia adalah mr². This half mr². Okay, so means that depends, the moment of inertia obviously depends on the mass, right? Okay, and also the axis of rotation. Sebab tu kita nak ukur R ni lah. Kalau kat sini lain lah. Kalau axis of rotation dia dekat sini, R dia kat situ. Kan? Kalau dia dekat sikit dengan sini, axis of rotation dia, R dia akan lagi kecil lah kat sini. Okay? So mass, axis rotation. Yang dia nak adalah factor that not influence the moment of inertia. So the answer is C. Okay? Alright, so finish exercise 1 for UPS 2. So now let's proceed to set 2, okay, which is exercise number 2 for your UPS 2. Alright, question number 1. A block of mass M is moved over a distance D, okay, and applied force F is opposite to the block displacement. Okay, so kita nampak dekat sini F is opposite direction dengan block displacement. Maknanya kalau lah block displacement dia direction dia ke kanan, sebab dia dah nyatakan F dia opposite direction iaitu ke kiri. So maknanya angle dia adalah 180 degree. So how much work is done on the block by the force F? So means that WF is equal to Fs cos 180 degree. So cos 180 degree you akan dapat negatif F lah. S kita kat sini dia pakai D kan. So negative FD. So the answer is C. Number 2, a ball is dropped from a height and falls freely. Okay, the gain in kinetic energy of the ball is, okay, maknanya kalau masa dekat atas tadi dia mesti ada gravitational potential energy yang besar, kan? Tapi bila dia jatuh ke bawah, sekejap saya lukis. Macam ni kan? Okay, masa dekat atas ni, mungkin dia punya UG dia 1000 joule. Okay, masa dia dekat bawah ni pula, mungkin UG dia dah kurang lah sebab height dia dah berkurang. So mungkin dekat sini 800 joule. Mana lagi 200 joule? Okay, that's mean kinetic energy is equal to 200 joule. Okay, so you can see here that, okay, the potential energy, okay, the gain in, sebab dia kata ayat di sini, the gain in kinetic energy, okay, pertambahan kinetic energy itu, okay, is equal to the potential energy of the ball. Kan, maknanya jawapan dia yang betul adalah C lah. Okay, so jadi the gain in kinetic energy of the ball is equal to the potential energy of the ball. So kalau asalnya tadi potential energy dia adalah 1000, so semakin dia turun ke bawah kan, semakin dia nak sampai dekat bawah tu, okay, kita boleh nampak kat sini. Jadi dia punya kinetic energy dia akan samalah, which is 1000 joule, which is equal to, okay, gravitational potential energy dia masih dia dekat atas tadi. Okay, so question number 3. Okay, where is the roller coaster gaining potential energy? So maknanya dia bertambah lah potential energy dia kan. So mestilah masa dia semakin naik, A to B dia turun, B to C lah yang dia naik, C to D pun sama dia tu turun. So paling senang lah ini. Okay, number 4. A particle is thrown upward with some kinetic energy. What happened to its kinetic energy at the highest point or height it reaches? Okay, so means that daripada bawah ni kalau kita baling, dia kata dia baling dari bawah, so dia ada kinetic energy. Sampai ke atas tu kinetic energy tu akan convert kepada gravitational potential energy. So this is the height. Okay, so at that point, the gravitational potential energy should be maximum. But the kinetic energy is 0 since V at maximum height is equal to 0. Okay, so question number 4. Its kinetic energy is lost? No. Its all kinetic energy is absorbed? No. So its all kinetic energy is absorbed by the air? No. Its kinetic energy is convert to potential energy. Itu yang paling tepat. Okay. Alright, question number 5. What is power? So this is very easy. The rate of work being done. Okay, C. And then number 6. A body is traveling in a a body is traveling in a circle at constant speed. So this is chapter 5 under circular motion. Okay. Okay. So it has constant velocity. Betul ke constant velocity? Salah. Okay. Constant speed, yes. Okay, constant speed betul. But the velocity is not constant. Tadi kan kita dah discuss kan, velocity dia tak constant, magnitude dia constant. Okay, 10. Contoh kan. Magnitude dia constant, tetapi direction dia tidak constant. So bila direction dia tak constant, so maknanya dia punya velocity is not constant. Okay. Has no acceleration? Salah. Ada acceleration. Has an outward acceleration? Salah. Dia adalah centripetal acceleration, which is inward acceleration. Okay, so the answer is D. 7. When a particle moves in a circle with a uniform speed, okay, its velocity and acceleration are both constant. Tidak, dua-dua ni tidak constant sebab berubah arah. Kan kita dah discuss tadi. Okay, direction dia berubah. At this point upward, AC to the left. At this point to the left, AC is downward. Okay, so you can see here that the direction of V and AC always changing. Okay, so its velocity is constant? No. Velocity is not constant. Its acceleration is constant? No. Yes, this is the correct one. Its velocity and acceleration both change. Okay, 7, the answer is D. Alright, diagram below shows a car moving in a circular motion on an unbanked road. What type of force that acts on the car to keep it turning in a circular pathway? Alright, so remember here we have direction of the centripetal acceleration towards to the center of rotation. V must be tangential to the circle. And then what is the force yang ada pada kereta tersebut so that dia boleh pusing corner tu dengan jayanya. Okay, so remember for this case, the only force that provide the centripetal force when the car try to turning a circular pathway, so it is the frictional force. Okay, that's why we can write the total FC is equal to MAC. So here we should put frictional force, alright, and it is equal to MAC mu n equal to mv squared over r, and then you can derive until you get an equation of V. Okay, so the answer is friction. Ingat friction je. Number 9. Which of the following definitions is false about the angular parameters? Angular displacement is the change in angular position. Betul. Okay. Average angular velocity is the rate change of angular displacement. Betul. Omega. Okay, the rate change of angular displacement. Okay. Instantaneous angular velocity is the rate change of angular displacement at an instant. Betul. Average angular acceleration is the rate change of the velocity with time at an instant. Salah. Okay. Okay, salah sebabnya disebut sini average tapi kat belakang ada perkataan at an instant. Okay, so the answer is D. Number 10. A merry-go-round spins freely when Digo move quickly to the center. So, this is a conservation of angular momentum. Okay, so we have the merry-go-round here. Okay, so kita tahu merry-go-round ni dia akan ada dia punya moment of inertia. And then kita ada Digo. Digo ni mungkin budak kecil kat sini, duduk sini. Okay, dia pun akan ada lah dia punya moment of inertia of Digo. Okay, but the moment of inertia Digo, okay, but the Digo's moment inertia, okay, this is the R. So we can calculate ID, which is the Digo's moment inertia. So it's equal to mr squared. So masa dia duduk ujung dekat merry-go-round ni, so inilah dia punya R lah, jauh sikit. But what happened when Digo move quickly to the center? Okay, you boleh cubalah kalau ada boleh jumpa kat mana-mana merry-go-round, dia pergi dekat sini, kat color biru ni. So you can see that R here is decreasing. Sama macam tadi, when R is decreasing, I is decreasing. So when I is decreasing, omega angular velocity increase. So when Digo move quickly to the center, okay, dia akan nampak sendiri perubahan. Okay, di mana merry-go-round ni akan rotate semakin tinggi. Dia sama je macam soalan yang depakan tangan tadilah. Okay, so contohlah conservation of angular momentum initial equal to final. Okay, kita tengok dulu. Alright. So kalau tadi masa dekat hujung tadi, sama jugalah. Kan? Dia punya moment of inertia dia masa dekat hujung, dia duduk jauh, besar sikit lah. Contohlah dia punya tu adalah 50. Okay, omega naught dia, initial angular velocity dia 20. So, 100 lah. Total angular momentum, 100 kg meter squared per second. And then, I final, masa dia pergi ke tengah sikit, dekat rapat sikit dengan tengah, okay, the moment of inertia Digo tu sendiri akan berkurang. The moment of inertia Digo akan berkurang. So, dia akan tambah dengan moment of inertia untuk merry-go-round. Okay, sebab yang final ni, I final, kita akan tambah. I Digo tambahkan dengan I merry-go-round. Okay, IM ni dia constant. Selepas moment of inertia untuk merry-go-round tu tak berubah. But for the whole system, bila kita tambah dengan Digo, so the moment of inertia Digo tadi bila dia lari ke tengah sikit, dia akan berkurang lah. That's why I final dia akan berkurang. Kalau kita letak nilai dia adalah 20, so obviously angular velocity dia, final angular velocity dia akan jadi besar lah. Kan, kita compare macam tu senang nampak. 20 dengan 50. Okay, increase. So, the correct answer, the moment of inertia of the system increase. Salah. Bila dia lari ke tengah, dia bukan increase. The moment of inertia I final should be decrease. So, salah. The moment of inertia of the system decrease. Betul. And the angular speed decrease. No, angular speed should be increase. The moment of inertia of the system decrease. Yes. And the angular speed remains the same. Salah juga. Okay, the last one. The moment of inertia of the system decrease and the angular speed increase. So, ini yang betul. Okay. So, number 11. To increase the moment of inertia of a body about an axis, you must, to increase the moment of inertia of a body, you must increase the angular acceleration. No. Decrease the angular velocity. No. Increase the angular velocity pun tidak. Place part of the body farther. Macam dia depakan tangan tadi kan. So, tangan dia part of the body, right? Okay, so the part of the body is now farther from the axis of rotation. So, R dia akan increase lah. So, I dia pun akan increase. So, the answer is D. 11, the formula used to find a torque. So, torque is equal to F dot ke cross. Yes, F cross R. Cross product. So, dia akan jadi FR sin theta. Okay, so F cross R cos theta salah. F dot R salah. Betul. And this is also salah. Tiba-tiba ada mg, kenapa kan? Okay. So, the formula used to find a torque. Okay. So, kita ambil yang paling tepat adalah question number 11. The answer is, that one is 11, right? Okay. So, the answer is C. Okay. So, this should be, I think this should be question number 12, right? Yang tadi tu 11. Sorry, 10 ada 2 kali. So, this one should be 10. 11. Okay, this should be 12. And the last question, what happens to the angular velocity omega of the student when the masses is moved away from the axis of rotation? Okay, contoh yang asalnya yang inilah. Contoh sama juga macam tadi. Dia akan ada I initial, right? Maknanya I of the student and the stool tambah dengan I untuk mass 1 plus I untuk mass 2. So, bila kita kira, the moment of inertia masa tangan dia rapat ke dada dekat dengan axis of rotation, kita akan ada ISS plus 2IM lah, the mass. So, we need to consider the moment of inertia as a particle. So, kita boleh nampak sini IM, formula dia adalah mr squared. Okay. Sama jugalah. Kan? So, bila R is increasing for the second part, when R is increasing, automatically the moment of inertia final akan increase. I stool tambah 2I of the masses. Okay? Okay, so I ni akan increase. So, IF dah akan increase lah. So, remember when the moment of inertia is increasing, okay, maknanya bila dia depakan tangan dia, okay, the masses is moved away from the axis of rotation. I is increasing. So, omega, dia akan rotate lebih perlahan. Kalau tangan rapat ke dada, tangan dekat dengan axis of rotation, moment of inertia dia lebih kecil dan dia lagi mudah untuk rotate, and then the angular velocity dia akan lagi besar. Okay, so jawapan kat sini, what happened to the angular velocity? So, the answer is decrease. Okay, tak adalah stop terus zero, decrease lah yang paling tepat. Okay, maknanya kalau dia depakan tangan ni, dia akan decrease slow sikit. Lepas tu dia rapatkan balik. Kalau you cuba buat kat rumah, you boleh buat. So, dia rapat balik dia punya masses ke axis of rotation, rapat ke dada sikit macam tu. So, dia akan rasa dia laju sikit. Okay, kalau you search dekat mana-mana YouTube pun banyak jugalah orang tunjuk. Okay, so kita berhenti dekat sini. Itu sajalah untuk video kali ini. Saya ucapkan selamat berjaya. Semoga awak boleh skor dengan baik untuk UPS 2. Jumpa lagi. Assalamualaikum dan selamat sejahtera. Bye-bye.